In today's video, we're going to use SLIKWORKS to do an FMEA for a camera display system. The camera display system that we've chosen in mind here is something that is used in an automotive application. Sometimes you can replace the side mirrors of the car with a camera. To do that because it improves the aerodynamics of the vehicle. But replace the side mirrors of the car, put a camera in there, and also put a display so that now the user, instead of looking at the mirror, they look at the display to see if there is any vehicle on the side, any blind spots, and then warn to the driver. We're going to do a simple FMEA for this using SLIKWORKS. This is the SLIKWORKS dashboard. As you can see, it's a list of all the projects. We're going to start a new project. We're going to call it camera display system. Camera to display all. All right, I'm going to create a project. And once you go into the project, uh, on the left, you'll see a bunch of options open up as to what kind of safety analysis that we can do. For now, we're going to stick with FMEA, and there is still the option to modify details about the project over here, but we're going to go to FMEA. The first thing you'll see again is what templates that can be used. For the purpose of this exercise, we're just going to choose a default template. There is another video which talks about how to use custom templates and how to customize a template. But for now, we use the default template. The first thing it's going to ask is uploading an architecture diagram. Now I'm going to upload the architecture diagram, and then quickly we're going to take a look at what the architecture diagram looks like. All right, I'm going to open the architecture diagram here. Essentially, what it is there is a camera on the left side, there's a camera on the right side. It's sending, uh, there's a serializer, deserializer. The serializer is on the camera, which converts LVDS CSI2 messages into GMSL2, sends it to a deserializer, which is on the CPU side. The CPU, then the deserializer deserializes this, sends this information to the CPU, where all the processing of the image happens. This image is then displayed to a display. It's assumed that the display is very close to the processor, which is why there's no serializer deserializer here. And it's basically a display port that's connecting the processor to the display. As an example, we've considered Raspberry Pi 5 as the processor. One can use any other ASIL rated processor. But essentially, this is what it is: camera information sent to the CPU, processed in the CPU, and then displayed onto a display. The same process happens from the right side camera, and then there is also a vehicle control unit, which is just transmitting information about the vehicle speed, errors in the vehicle in general. All of this is transmitted to a transceiver. The transceiver is then sending the information to the Raspberry Pi 5. So this in a nutshell is the architecture, and the goal is, given this architecture and given a few other information, how do we do an FMEA? So once we have the architecture uploaded, I'm going to use this extract AI, use AI to extract components. So what this is doing is there are some image recognition algorithms, which it scans all of this architecture, it sees each element, their signals, and then it tries to spit out all the elements that it identifies. Then, as you can see, the tool does its magic. identifies all the components, and here it's just listing out all the components. As an example, if you take the left side camera, which is, let's say, one of the first components, uh, that's that's what shows up here. The left side camera, and I believe it's putting it in ascending order. So left side camera, if you look at this, it talks about all the inputs and outputs as well. So for the left camera, essentially the input is the environment outside. There's no signals that are the input. Uh, However, the outputs are the data packets that it sends out to the serializer. If you look at this, it's the data 1 to data 4 and CSI to frames. It's a 4-channel CSI to frame, and it can be configured whether it's 4-channel or 2-channel depending on the resolution. There's also a clock signal. These are some of the major signals that are used. Similarly, the signals, the elements from other components are also identified. One of the power of SLIKWORKS is it is able to digest any architecture, any image, and can identify all the elements in that image, all the I/O in that image, and spit it out in a format that can be used to perform an FMEA. So right now, it's identified all these elements. So now we have the elements and their I/O. Then what happens is it asks for a list of effects and existing safety measures. Now we're assuming at this point the HARA is completed and there is a list of, let's say, hazards that are identified. Um, there are a couple of ways to go about this. One, you can manually add the system effects. Two, you can upload an image. And three, which is something that we're going to be working on, is to create a HARA within SLIKWORKS so you can just directly link the hazards in SLIKWORKS. I'm going to choose the option of uploading an image. And here I have three hazards, and I'm going to upload an image. It's basically an image of the hazard and hazard their ID. So these are the three hazards: the loss of display of images, delayed display of images, and partially rendered images. Now, once this is done, we can also upload an image of all the safety mechanisms that we've identified. Let's say in the technical safety concept, which would be here. So I'm going to upload this, and then it does its the again the image recognition algorithm. It identifies from the image all the mechanisms, its description, its ID, and it just uploads it over here. So we've identified a few mechanisms over here, like camera loss of image monitoring. But what this basically does is it takes a loss of image in the CPU. If there's a loss of image, then it performs some action to inform the driver there's a loss of image, don't trust the camera. So once this is done, we're now in the effect sheet, then we go into the form sheet. And then we do a generate form sheet. So what happens in this step is the tool now takes information from architecture, which is it has all the elements. It takes the effects, and then it takes the safety measures. And using this, it creates a form sheet. So the way it does it is it takes each element, it identifies some failure modes for each element. It could be two, three failure modes, which is built on a database. For each of those failure modes, it combines it with a given effect, which is given over here. And then it tries to see, given the effect, given the failure mode, then it also tries to predict the cause, given the effect, given the failure mode, given the effect, given the cause, what is the best safety measure to prevent it? This is what the form sheet is going to look like. So once